Hi there! Today I have a nice Kenwood TS-570 for you, and this radio came in with 3 different fault descriptions, and well, we need to investigate it. First of all, the owner told me that he has problems with sensitivity, so he feels that the sensitivity is bad, so that is something easy to check out. And secondly, he told me he feels that the transmitter power is much below 100 watt, which is the power of this transmitter. And third, he told me that he recognized, especially on SSB, that the transmitter and receiver frequency seems to be off. So he has always to adjust the tuning knob a little bit to get to the right frequency. So that is what we want to check as well. Okay, so let us directly start, but we can check out what's wrong. And well, radio is already warm, so I left it switch on to have it in operation or on operation temperature. The same with the lab equipment, and so we can directly start. And okay, radio is in the 10 meter band, 28 megahertz, and it is set to upper sideband, which is normal, not really on 28, but anyway. So let's switch it to FM, because on FM we can check for the carrier, which was complained as well. And secondly, we can directly check the transmitter frequency, and then we know a bit more, and then we see what we will do then. Okay, so let's start. I press PTT right now, and wow, so 128, so the radio is putting out 28 watts over the spec, so there is obviously no problem with the transmitter, so maybe it is on a different band. But right here on the 10 meter band and on FM it looks nice, so I switch back to upper sideband, and now audio, yeah, peak is 130 watt. So yeah, on the 10 meter band, so there seems no problem concerning our power output. Okay, so then let's directly check what we have on our frequency counter. So radio is set to, as I said, 28 megahertz, and I switch back to FM, that we have the continuous carrier, and let's see what we have. Okay, yeah, so that is clear that he recognized some trouble on the radio bands. So the frequency is 120 hertz off, and yeah, I stopped talking to see. Yeah, for me it looks like that the PLL circuit is locking, so we only have the last digit jumping, which is more or less okay, so no problem. Now I'm still transmitting with 127 watt, and so what I want to see if with the amplifier output power we have a change in our transmitter frequency. So that would mean that the temperature, so the power amplifier temperature, would have an impact on our frequency. But as far as I see, there seems not to be a problem with with our frequency, so there is no drift when I'm not talking. So as long as I don't talk, it settles down, as you can see, which is okay. But still we have a frequency error of about 120 hertz, and that is definitely something what you can see on or what you can hear on the radio bands. So that needs to get adjusted, and it looks like that it is only an alignment question. Most likely the master reference oscillator, so the rock, is the guy who seems to be off, and we need to align it back to the frequency we have to figure out. It is somewhere around 10 or 20 megahertz, so we will see later in the service manual. But it looks like that we need to give the master oscillator an alignment. Okay, but anyway, first of all, we want to perform a master reset, because I want to avoid that something goes wrong on software side. So I just want the radio once reset it completely, and then I will double check if I have the same finding, and if so, then we go ahead with fixing it. Well, but before we gonna perform the master reset, I just want to see how the receiver works, and according the service manual, we should adjust the receiver to 29,800 megahertz, and we should switch the preamplifier on. So that is the advice, and the service manual is claiming with an RF output of approximately 630 millivolt at 8 ohm, we should do our synod sensitivity measurement. Okay, so the 630 millivolt you can see here on the level meter, and the manual is also claiming that we should put in a deviation of 3 kilohertz, what we are doing, and we should put the transmitter, so the generator level in this case, to minus 119 dBm, and with these values we should be able to read a SINAT which is 12 dB, a SINAT of 12 dB or better. So let's see what we can read and have a look. So that is really nice, and it is still without the CCITT filter, which is here, which would improve the SINAT as well. So it is still without the CCITT filter, and we are peaking for 20 dB SINAT, and the service manual is stating that we should minimum have 12 dB. So that means that the sensitivity according the service manual is really good. So no problem whatsoever. Okay, so then let us do the master reset, and well, that is important, that we really have a status where we can work on, because you know, it would be really not nice if there is a setting somewhere deep down in the menu that is changing this or that, and therefore it is important that we really start from zero, and therefore we will perform our reset. And therefore, first of all, I switch the radio completely off, and then I press and hold the A equal B button, which I'm doing right now, and now I switch the radio back on, and looks good. So the service manual is telling us, after displaying hello, which we what we have seen, the display is reset as follows. Display frequency is 14 megahertz, what it is. So alright, the mode is upper sideband, that is also good, and antenna is switched to antenna 1, which is right as well. Meter is switched to ALC, so that is also right, and the preamp is switched on. So that means now the radio is definitely set to 0, let me call it 0, and we can go ahead with now, yeah, so that is more or less, you know, the factory setting. When you get the radio first time and you switch it on, then you would see this screen, and that is what we have done right now, and we should go ahead exactly from this point. So, well, we can now do a real simple processor check, because with the up and down buttons we can switch between the radio amateur bands. And important for me is right now, if all the changing, so for instance upper sideband, we know that on the 40 meter band and 80 meter band we need to transmit on lower sideband. So it is now important to see if it will switch, and then on the 30 meter band, so that is basically CW band, and I'm interested if the processor switch it to CW, and with switching it to CW, we should have a fast ALC, and therefore I just do it, and I go, have a look. So here we have switched to fast, which is great, and it is set to CW. And now let's go to 7 megahertz, which is our 40 meter band, and you see it is already LSB, which is good. And let's go into the other direction. We can see that it is upper sideband, and here on the 12 meter band it is switching to CW, okay, and on the 10 meter band it is switching to upper sideband as well. So that looks good to me. From that perspective, we have now a very first impression, and now I'm gonna repeat our power measurement, and well, then we go ahead. Okay, I've switched the radio to the 17 meter band, and I will put it to FM, and let's see what power do we read. So 125, so that is exactly what we read before. So let me go down to the 160 meter, and I have to change. Okay, here it is pushing for 135, so for me it is a bit too strong, but anyway, so the feeling what the owner had is obviously not true. So now 80 meter band, so let me switch it to FM. Yeah, exactly the same. And on LSB, audio 1 2 audio. Yeah, so that is working as well. Now 40 meter audio, so that is okay, and on FM it is working as well. And well, let's go up to 14 megahertz audio, so it is working as well without any problem. And now 21 megahertz audio, 1 2 audio, so that is good in SSB, and on FM it is good as well. So now 12 meter, it is 127 on FSK, so no problem whatsoever. 129 on FM, and on upper sideband audio it is working as well, no problem. And once again on 28, 1 2 3 audio, so that is working as well. So yeah, what we can say so far, transmitter is definitely working without any problem. And then let's once again have a look onto our frequency counter. I go back to the 17 meter band, and I'm transmitting on 18100 megahertz, and let us see what we have. Yeah, so that is more or less the same picture. We are off frequency, and so the reading should be 18100, and you see we are 65 hertz off. So let me go back to the 28 meter band, not 28 meters, sorry, 10 meter band. Let's see what we have there. It is also, you can say, here we have it 100 Hertz off. 100 Hertz is off. So this improved a little bit. So maybe that our master reset did an improvement. I don't know, because it was definitely 130 and now we are approximately 100. But it can also be that it is a question of temperature. So anyways, the frequency is definitely off, and we know we have to align, we really have to align the frequency, and then we will see if we can get it fixed. Well, we need to open up the housing, and according to our PCB overview, our crystal will be down here somewhere, and also we have here a nice service. It looks like a compartment, but we can open the housing without taking off the complete. So we don't need to dismantle it completely, but I expect that we are not able to get to the point where we have to go, and so that is exactly what I have expected. So let me see if you are able to see what I see. Let's try it like this, and well, so that is now exactly the right way we see it here on our PCB plan. And what I can say so far, here is already, I can see here is already an optional filter inside. So it is a SSB filter, very nice. So this is an option. And well, yes, so as I already expected it, our crystal, our master crystal, seems to be somewhere in this area, you know, in this corner here, and therefore we need really to open up the complete housing. So I gonna do it off camera, because you know this is really boring. Okay, so cover is off, as you can see, but our complete it is at least the VCOs and the master crystal is down under this shielding. So to get to our oscillator, to the master reference, we need to take this shielding off as well, and you know, that is not really nice, because you know, if we take it off, then we will have a temperature drop, and that means that we will then have definitely a changing frequency. So therefore I just gonna take it off, see if it is possible to bring our tip in place, and then it would be really nice if I could close the housing. You know, it is always critical to do alignment like this with the complete housing open, because then we have a different temperature, and the different temperature will have an impact on the reference frequency. So I'm not really happy with it, but anyways, we have to open it, and then we will see what we can do. So screws are out, and now I hope I can lift it off. And yes, of course I can. And well, what you can see, unfortunately there is not the TCXO option inside. So if you watch down here, you can see this is the TCXO option. So this is not implemented. That means this here is our crystal, and this is our master crystal. And when I now check simply with my fingers for temperature, I recognized that it has a decent temperature. And now, you know, everything is off, and well, now we definitely have different situation, and that is not nice. So anyways, let me connect our counter to the test pin 505, and yeah, can we see where the test pin 505 is? Yes, I can see it. Let me see if I can show it to you as well. Maybe I have to move it a little bit, like, where are we? Like so. Yeah. So we need to measure it down here. So that is our test point, and then we have here our TC 500, and that is our adjustment point for our X500. And yeah, X500 is, as I already said, the master oscillator. Okay, according our service manual, we have to do some presetting. So the reference oscillator is 20 megahertz, and we have to do, as I said, some presettings. So radio has to be set to 14750, mode is AM, and we have to connect a counter to test point 505, and then we should read 20 megahertz, and we should have maximum plus minus 20 hertz off. So yeah, that definitely means we need to be very accurate. Okay, presetting done, 14750. It is set to AM, and that means we can directly start. And this is a hour of truth. So what we see is that we are 82, 81 hertz off, and that needs to be realigned to exactly 20 megahertz, and then our circuit, our PLL circuit, should work again. So I hope that we can hold the temperature. So therefore let me start very quickly that we get it to 20 megahertz. Okay, I have already started, and it is really fiddly. So, oh yeah. Oh yeah. So that is funny. Oh yeah. So that is really a challenge, as you may see. So that means it will take a while. So let me do it off camera, and I show you the result. Okay, so that has taken a while, and as you can see, it is within 1 Hertz tolerance, and our allowed delta is plus minus 20. But now we may have already a temperature impact. So what I'm gonna do right now, I leave it as it is, and I put the shielding over it to get the right temperature, and then we gonna check it once again. I've once again readjusted it, and you see it is absolutely on frequency, so that is okay. So now the frequency counter is back to the antenna jack, and radio is adjusted to 14 megahertz, and let's see now what we have. Yeah, so we have only 1 hertz off, and that is, from my point of view, very good. So let's do the same on 18100. Now it is on 18100, and again 1 hertz off. So that is excellent. And then let's check once again 21 megahertz and 21 as well, 1 hertz off. And remember, so 20 hertz is the allowed delta, and we are right now only 1 hertz off, and you see it is jumping to 21. So the transmitter frequency is now excellent and precise on the frequency where it should. So let us once again go down to 14. Yeah, you see, excellent. So it is precise on the transmitter frequency. That is great. Okay. Well, and the same test on the 10 meter band, 28 megahertz, and we have 28, and here we are 3 hertz off. So that is really good. So I change now to 28,500 just to see what we have then there. And yeah, so that is great. That is really great. So we really can say now the radio is absolutely on frequency without any problem. So that is perfect, no problem, and I would say we can leave it as it is right now. Okay, and at the end of our alignments, let us finally check our output power. So yeah, it is 130 watt. I have already tested it all over the bands, and it is always close to 130. Well, for me, it would be a bit too much. So 130 watt is a lot of stress for the final. So I would like to put it down to 1995. So that is a good value. But the owner told me that he is using an old tube amplifier, linear amplifier, and this amplifier needs a bit more drive. So okay, we leave it on 130. I mean, this radio has really a good heatsink, so I hope that the stress for the final stage is not too hard, but in any case I wouldn't leave it there if the owner did not ask for it to leave it there, or verify that it is around 130 watt, because that is what he needs. Another important point I wanted to verify is the S-meter alignment, and radio is feeded with minus 73 dBm, and as you can see, it is exactly on S9. So the S-meter on SSB is okay, so we do not really need to align it on SSB. That is fine. According our service manual, I wanted to verify the sensitivity on the shortwave SSB band as well, and radio is switched to upper sideband, and our service manual is telling us that on 14.100 in upper sideband with adjusted signal generator to minus 119 dBm, we should reach 10 dB signal to noise, and that is what we're going to check right now. As you can see, generator is set to minus 119 dBm, and I'm reading the SINET, which is signal to noise plus distortion, and we are reading still 16, approximately 16 dB SINET, and you know, that is better, much better than the specification is telling us. So specs is asking for 10 dB signal to noise without distortion. So you know, if I'm reading the SINET value with 16 dB, that is even better. So the radio really has a very nice receiver performance, so there is nothing to complain. And the service manual is telling us all these values are taken with preamp on, and that is what it is right now. Preamp is switched on, and now watch here the SINET value. I'm gonna switch the preamp off, which is now, and we are still reading a SINET with 10. the service manual is telling us if we are switching out the preamp, then the sensitivity will drop by 5 to 15 dB. So our value dropped. So let me switch it on. So now it is again 16, and now I switch it off and we are down at 10. So that means if we are switching off our preamp, then we have a delta of, let me say approximately 6 dB. That means that what our specs is telling us, so the radio is within these specs, and what we should highlight here is that even with switched off preamplifier, the signal to noise plus distortion is still better than what is written to our service manual. So, you know, this radio is really good. Now I want to switch it back, and now I'm interested where is really the lowest point, and I'm watching here for 10 dB. So with 10 dB we really have reached the lowest sensitivity. Also a lot of colleagues are measuring this with 3 dB. You know, 3 dB is already a very, very weak signal where you do not really where you are not really able to read what the distant end is telling you. So I like to do it with 10 dB SINAT, and then I'm sure this is really a level where you can read distant end. So okay, so let me go down until we have only 10 dB, and this is somewhere here. Yeah, I would say so. Now, yeah, it is, that is approximately 10 dB. And look at this. So minus 120. So this is almost minus 127. And that is really, really, really a good sensitivity. So that is really a great performer. And if I now switch on the speaker, you can hear, so let me make it a bit louder. So you can still hear the tone in the noise, and the signal what we are injecting is really incredible tiny, you know. So that is almost nothing what is now sent to our receiver. So therefore I can say the receiver performance is excellent, no doubt. So, and to summarize, now you know, the radio is back to a nice frequency setting. So radio is within 1 or 2 or maximum 3 hertz, depending on the crystal temperature inside. And I've measured the radio cold, when it is absolutely cold, and under this condition there is only a frequency offset of 13 hertz, and that is excellent. And if it is on operation temperature, we have approximately 1 to 3 hertz off, so that is great. So power, transmitter power is approximately around 130 watt, so that is okay. As you know, this is only because the old man has to drive an old tube amplifier, so okay, that's fine. And third, our receiver sensitivity is great, so that is close to sensation. So that is, you know, incredible. And we have checked our S-meter performance, so that is good as well. And therefore, I would say we can give the radio back to the old man. And well, if this video was a bit interesting for you, I would like to ask you, give me please a big thumb up for this video. And well, catch you next time. Bye.